In this video, we're going to be taking a look at the Gilman reagent. It's a great way to make carbon-carbon bonds in organic chemistry. Let's get started. We can take a Grignard reagent. Remember, that's a negative carbon atom, and it's with a magnesium bromide or magnesium chloride for the Grignard reagent. So let's say we had this negative, attacking, aggressive, negative carbon atom, whatever group's on here, it doesn't really matter. And let's say we want this negative carbon to backside attack a methyl of methyl bromide with a good leaving group on it, sort of an SN2 style reaction. This would be a great idea because then we can make this carbon attach to that carbon and make a carbon-carbon bond. And we can make bigger and bigger molecules in organic chemistry. That would be a great thing to happen. Unfortunately, this doesn't work. A negative Grignard, negative carbon on a Grignard, does not do an SN2 style reaction. But don't lose hope. There's another way of pulling this off. And this other way is using a molecule, a reagent similar to a Grignard, called the Gilman reagent. So let's take a look at a Gilman reagent. A Gilman reagent is made by taking some R group with a good leaving group on it, 2 molecules of that. We add some lithium to it, a couple of equivalents, and we make some kind of organolithium. So this could be a methyl, an ethyl, a propyl, whatever you want with a good leaving group. React it with the metal lithium, and you can make this negative carbon with a positive lithium on it. But we're not done yet. We take those 2 organolithium reagents and we add a copper 1 compound, copper 1 iodide, CuI. And so we have a pretty good leaving group on here and the copper compound. What that makes is a copper compound where these 2 negative carbon groups are attached and you have the lithium attached. So you have a positive 1 for this lithium, a positive 1 for that carbon, and a negative for each of those R groups. So I want you to think about this like a carbon, the R group, having a negative charge in a lone pair, and it's ready to go attack. So this Gilman reagent, with these negative R groups on it, can do a substitution reaction like we just saw. So for instance, I could take and make, let's take methyl bromide. We add lithium to it. We add our copper iodide. So I want to think about this like CH3 with a negative charge, ready to go react. And now if I take a good leaving group, I can replace the bromine with my alkyl group. But I have to use the copper lithium reagent, the Gilman reagent we call it. So you can take any kind of alkyl halide. Let's take, isopropyl bromide. 2 of those. Add our lithium. We add our copper iodide to make our Gilman reagent. So we get 2 of these on the copper and the lithium. And you could take that compound, maybe I would draw it like this, 2 of those on the copper lithium. And we can react that with any kind of R group. You could react with propyl bromide and you would make propyl with an isopropyl on it. You could react even with leaving groups on double bond things, like a phenyl bromide. And you directly replace the bromine with whatever the R group is. Any kind of double bond compound even. So you replace the leaving group with whatever the R group is. This is my Gilman reagent. The copper lithium with 2 organic groups on it, and then those can directly replace a bromine and make new carbon-carbon bonds, which is awesome. Take a look at some of my other videos on organic chemistry and subscribe to the channel.